Okay, so this is the first of two videos I'm going to make on chemical equations, word equations and symbol equations. As we've got here, how to work out word equations and how to balance symbol equations. Now, word equations just show which reactants form which products. They simply show us what we start with and what we end with. And they just name reactants and products. So calcium carbonate reacts with hydrochloric acid to form calcium chloride, water, and carbon dioxide. That sentence can be summarized in a word equation. Calcium carbonate plus hydrochloric acid, what I start with, reacts with is indicated by the arrow. It kind of represents the change from our reactants to our products. And I get calcium chloride, water, and carbon dioxide. Another. Magnesium and oxygen combine to form magnesium oxide. My word equation, what I start with, magnesium and oxygen, they're reacting together to form magnesium oxide. Last, sulfuric acid reacts with sodium hydroxide to form sodium sulfate and water. For my word equation, what I begin with, sulfuric acid and sodium hydroxide. My sentence said reacts with, and that's indicated by the arrow. I get sodium sulfate and water. Done. Now, moving on to writing and balancing symbol equations. Actually, we're really only balancing the equation. To complete an equation, it has to be balanced. To present a written equation, got to be balanced. And it will include state symbols and ionic equations. I'm dealing with those in the second video, part 2. You will never be asked to work out the formula and figure out the symbol equation. But once the equation is given, you just have to balance. That means we must have the same number of atoms of each element on both sides of the equation. Now, when balancing, we never change a chemical formula. It's fixed. I've already made 2 videos on how to work out the chemical formula of anything you're going to need, except organic. That's different. And we use coefficients. These are just numbers we can place before a chemical formula. For example, HCl will always have chemical formula HCl. That's fixed. It can't be changed. If I need to have more hydrogen atoms, I can only use a coefficient. I can say HCl can become 2HCl or 3HCl. But I've got to remember that will also give me more Cl. So stressing this because it's a place where a lot of people go wrong. When balancing, we never change a chemical formula. I'm given the formulae of a number of substances involved in a reaction. I begin with CaCO3 plus HCl. The arrow shows me that these react together to form the products. Now, I'm starting on the left-hand side. I see Ca. I've got 1 in CaCO3. CaCO3 is telling me I've got 1 Ca, 1 C, and 3 O's. 1 in the beginning, 1 at the end in CaCl2. Balances. Notice I'm working from left to right with the reactants. I'm not going to miss anything. Next, C. I've got 1 C in CaCO3. And if I go to the end of my products, I get CO2. 1 there as well. Balances. O is next. CaCO3, well, the 3 tells me there's 3 O's. In my products, I've got 1 in H2O, I've got 2 in CO2, that's 3, it balances. Only got H and Cl to go. In my reactants, I've got HCl. So one H there. In the products, I've got H2O. Two H's in the products, so work to do. Now, the only way I can increase the number of HCl on the left is by adding another HCl. What I've got here. But if I do this, I'm increasing not just the H, I'm also increasing the Cl. I've now got two Cl on the left. And that's all right because I've got CaCl2 on the right also. It's easier, rather than write plus HCl twice, it's easier to write plus 2HCl. Now everything goes, just checking. CaCO3, 1 Ca. I've got 1 in CaCl2. 1 C. I've got 1 in CO2. That's good. 3 O's. On the right, I've got 1 in H2O. I've got 2 in CO2. 3 altogether. That works. I've got 2 HCl, which means I've got 2 H's. I've got H2O. That's 2 again. That works. 2 HCl also means 2Cl, and I've got 2 in CaCl2. We're balanced. We're done. Another. A little bit more complicated. I've got groups of atoms here. Magnesium nitrate, that's MgNO3 twice, plus sodium hydroxide, that's NaOH, gives magnesium hydroxide, that's MgOH twice, plus sodium nitrate, NaNO3. Now, I know a lot of people would look at this and say, okay, on the left, I've got 1 Mg. I've got 2 Ns. And I've got 6 O's, but wait, I've got 1 in the NaOH as well, that's 7. And it's already getting complicated. The way to do this is to say the NO3 is as a group, NO3 on the left, and also as a group, NO3 on the right. Treat it as a group. Treat it as just one thing. Mg, 1 on the left, 1 on the right. I know I've got work to do with my NO3s. I've got 2 on the left. I only have NO3 once on the right. Na, 1 on the left, 1 on the right to begin with. OH, I've got 1 on the left and 2 on the right. So my problem is going to be with my groups. Mg and Na balance. 2 of the NO3 groups on the left, I must have 2 on the right. Let's do that. So I start by saying 2 NaNO3. That being the case, I've now increased my number of Na. I've got 2 on the right. I need 2 on the left. Put the 2 there. That also increases my 2 OHs. 2 NaOH contains 2 OH groups, but I've also got 2 on the right. Everything seems to balance. Let's check. Mg, 1 on the left in MgNO3 twice. 1 on the right in MgOH twice. Balances. NO3, I've got 2 of those groups, but I've got 2 NaNO3 on the right. Balances again. 2 Na on the left, 2 Na in 2 NaNO3 on the right. Balances again. 2 OH groups on the left. I've got 2 OH groups in MgOH2. Everything balances, and as I've said, the last few words, all equations always do. Now, my rule, if I have an element there, I'm going to balance it last. I look at my formula given, C3H8 combining with O2 to make CO2 and H2O. C3H8. Now, I'm going to repeat because I think it's very important. If you've got an element on its own, balance it last. I could put whatever I wanted in front of the O2. It's not going to affect C or H. Balance for C. C3H8 means I need 3 carbons on the right means 3 CO2. Right, we started. H8 means 8H on the left. I need 8 on the right. 4H2O. My number of C and H now balance. C3H8, 3 carbons, 8 hydrogens. But that's okay. 4H2O is 8 hydrogens. I've only got oxygen to think about now, only got O to worry about. On the right, I've clearly got more O on the right than on the left. On the right, 3 CO2 gives me 6 oxygens. 2 in every molecule of CO2, I've got 6 altogether. 4H2O gives me 4 oxygens. 6 plus 4, that gives me 10 on the right, so I just need to have 10 on the left. Put the coefficient 5 in front of the O2. And there's my final balanced equation. Okay, C3, 3 carbons, but 3 CO2, that's okay. H8, that's 8 hydrogens. 4H2O balances. 5 O2s, that's 10 altogether. I've got 6 O's in my 3 CO2. I've got the other 4 in my 4 H2O, and we're good. Now, part of my decision to choose this equation and the next one is that they're very similar. In fact, I'm starting off with the same reagents. What's different in this one is I'm getting CO2. In the next one, I'm getting CO. Not our problem. If we're balancing equations, we don't need to worry about the formulae as given. They're provided to us. Our job is to balance. I can again balance for my C and H first. C3H8, 3 C's to begin with, 3 CO. Done. H8, 8 H's to begin with, 4 H2O. That's 8. Done. O, many more on the right. Let's look at the right. 3 from the CO, because there's 3 CO. 4 from the H2O. That's 7. 7 on the right. How can I get 7 on the left? I would have to say 3.5 O2. 3.5 times 2 is 7. That now balances. Now we leave ourselves here. C3H8 plus 3.5O2 gives 3 CO2 and 4 H2O. It works. Everything balances, same number of everything on both sides. But we can only use whole numbers on both sides. So quite simply, I just double. 2C3H8 plus 7O2 gives 6CO plus 8H2O. I put what I want in front of the O2 and here, that was very important because when I did everything with number just to balance, I end up with a half. Get rid of the half by just doubling. Last slide. Ca plus HCl gives me CaCl2 plus H2. Pause the video for a second, have a look, then I'll resume. So starting with the Ca, 1 on the left, 1 on the right, so far so good, that balances. Now to H. 1 on the left, but it's H2 on the right. That's 2 hydrogens. What I need to do now is to increase my H's on the left by using a coefficient. Ca balances, H balances, Cl is left. 1 Cl in HCl, but I've got 2 HCl, that's 2. It balances. And my completed equation would be here. Next, pause the video for a second, have a look, see what you think, then I'll figure it. So going from left to right, I've got 1 Na to begin with. I've got 1 Na on the right-hand side at the end. I've got two H's to begin with. I've got 1 plus 2, 3 on the right. H is my problem. I've got one O on the left and one on the right. Everything balances except H. 2 to begin with. 1 plus 2 is 3 at the end, but I'm not worried because H2 is there as an element. I can put what I like in front of an element. And if I do this, I've now got 1H in NaOH. I've got 1H in a half of H2. 2 on the left, 2 on the right. And I think you know what I'm going to do next. I am just going to double everything. And there is my final equation. One more example. All right, so from left to right, I see groups. I'm taking my SO4 as one group. I'm taking my OH as one group. That's going to simplify things. Let's go from left to right. 1 Mg on the left, 1 on the right, great. 1 SO4 on the left. I see one SO4 group as a group on the right in Na2SO4. That's good. 1 Na in NaOH, 2 in Na2SO4. I need to use my coefficients. I need to say 2 NaOH on the left. Now Na balances. NaOH, that's one OH, but I've got two of them now, so that's two OHs. I've got two OHs at the end. Everything balances. Final check. 1 Mg on the left, 1 on the right. Great. 1 SO4 group on the left, 1 on the right. Good. Na, well, I've got 1 in NaOH, but I've got 2 NaOH. That's 2 NAs, and I've got Na2 on the right, balances. 2 OH on the left. I've got MgOH2, that's 2 OH on the right. Everything balances. And what I've got is that by here. Done. Everything works, and that's it. I'll make my second video on chemical equations next. If you found this useful, please like and subscribe. That really helps me. Okay, thank you for watching.